So, welcome to the last session today, creating PDFvt. My name is Stephan Mühlstrasser from PDFlib in Munich. So, let's have a quick look what I will be talking about. I will give you an introduction about PDFvt. Then I will discuss in detail the features that are defined by PDFvt. And as with all standards, there are some problems in them, and we did run into some of them. And I will talk about those. And I will present my conclusion, and I have some references later. A few words about me. I'm a software engineer at PDFlib GmbH in Munich. I was the lead developer for the PDFvt support in PDFlib, which we implemented in 2011. And yeah, PDFlib makes libraries for generating and processing PDF already since 1997. So the company is already quite a while involved with PDF. So, what was the motivation for creating the PDFvt standard? It's a format for variable document printing, VDP. We are talking about high volume printing, so many thousands or even 100,000 of pages that are printed, and they should be printed quickly. What kind of content is put in PDFvt? We have transactional content, so for example phone bills would be an example, or credit card bills, or promotional content that is personalized to individual recipients. So for example brochures that have individual text or images in them. And you can combine this transactional and promotional content, what we call trans-promo. So there are, for example, bills with promotion combined and sent to consumers. What were the challenges? The format was supposed to support rich graphical content, transparency, so you can create nice looking graphics, but at the same time the printers or RIPs must be able to process this graphics content with good performance. The format was supposed to support flexibility for production purposes, so you could target parts of the documents, for example, to different devices, that you could separate parts of the printing stream, for example, according to zip codes or things like that. So nothing specific is in the standard for that, but it has all the foundation that you can do all these things, as we will see. And one important thing is that you can embed arbitrary metadata that you then use, for example, for production purposes. And to sum it up, the intention was to create a standard-based alternative to many existing proprietary VDP formats. So, quick overview. We have an ISO standard 16612-2, which was published in August 2010. And this standard contains the definitions of multiple PDFvt conformance levels. PDFvt 1 contains all the data for a print job in a single file, so it's completely self-contained. You can send one file to the printer and everything is there. PDFvt-2 is for multi-file exchange. This allows to separate some parts of the file into separate files. So as we'll see, separate XObjects or ICC profiles can be separated from the actual page data. And PDFvt-2s is for streamed delivery. This is a format around PDF, a packaging format, which will allow generation of print streams while they, or the other way around, it will allow printing of streams that are actually generated on the fly. So you can start printing while not the complete data is received yet. All PDFvt variants are based on PDFX. And I think you heard already a lot about PDFX today, so I will not talk about that anymore. And it's important to recognize that PDFvt is a final format. So at the beginning, when people were starting to talk about PDFvt, some people said you need a special viewer or something like that, and that is not true. You can look at PDFvt files with a normal PDF viewer that must support at least PDF 1.6. So, for example, Adobe Reader 9 is perfectly fine for viewing PDFvt files. You cannot use any of the special features, but you can see it and you can print it on a normal printer without problem.
You really need a PDFX compliant viewer, because otherwise it's not recognizing all of the X base requirements.
Correct, yeah. Thanks. So, as we learned already, PDFvt is related to PDFX. PDFvt1 requires that the file conforms at the same time to PDFX4, and PDFvt2 requires that you have at the same time conformance to PDFX4P, PDFX5G, or PDFX5PG. So the special thing about these PDFX variants is that you can reference external entities. In PDFX4P, you have external ICC profiles as output intent, so in a separate file. With 5G, you have external graphical contents. You can reference XObjects in separate PDFX files. And a combination of these two features is PDFX5PG, external ICC profile as output intent and external graphical content. And there's even an additional PDFX standard.
K5N, but nobody uses it.
But that's not used, so I did not include.
It's not supported as part of PDFvt.
Correct, yeah. So let's look at a typical page from a transactional PDFvt document, an invoice. So the actual PDFvt document would consist of thousands of these invoices for individual recipients. And I would like to point out the recurring graphical content. So, for example, the company logo could be used globally for all invoices or other documents that are produced for a specific company. We could imagine that you put the image of a sales representative, so the customer knows who's responsible for him. And in the whole PDFvt print job, there would be many different sales reps that can appear on the pages. And we could also have a little image, a barcode, that appears exactly once because it's tied to this specific invoice. It encodes, for example, the address data for this specific recipient. And we'll see later that PDFvt puts knowledge about how often such an XObject is used in the document to enable optimizations during the printing process. So let's go forward to the discussion of PDFvt, and I'd like to start with the most important data structure that is defined by the PDFvt standard, and Olaf mentioned earlier today, and Leonard, that this will be in PDF 2.0 as well. And the DPart tree, DPart is the abbreviation for document parts. So this allows you to put knowledge about the different document parts into the PDF file. And what we see on the right here is a simplified image of the page tree structure in the PDF file. And what is added by PDFvt is are these parts here. We have an additional entry that is referenced from the document catalog, which is called the DPart root dictionary. And this contains always the so-called node name list, and this is just an example what I've written here, root recipient invoice. This is totally up to the creator of the PDFvt file. And we have a record level that is optional, and it can describe at which level in the document part tree the recipients are listed. And from there, the actual document part tree is referenced, and this is a hierarchical tree that starts with a root node and potentially many levels of other nodes below there. And the node name list contains names that describe what the role of these levels is. For example, we can call the root node root. Then we could have a level that makes it possible to identify the individual recipients of the pages in the PDF files. And we could have multiple document parts for one specific recipient. For example, you could have a header page and then multiple other pages. And how are the document part tree and the page tree related? Every leaf node of the document part tree has a reference to a range of pages. So this range must be non-empty. It must consist of one or more pages in the page tree. And the pages must be in ascending order. So a range is always without holes in it, and they must always be consecutive in the document. In the other direction, every page in the page tree must have a back reference to the document part tree it belongs to. So this data structure makes it possible to quickly access specific parts of a document through the nodes in the document part tree. So I think I said everything here. And the second important addition to the data structures of a PDF file is this so-called document part metadata. You can attach PDF objects to the document part tree nodes that describe what is contained in the document parts. And depending on the level in the document part tree, different kind of attributes can be attached to the document part nodes. So for example, you could attach to the root node who is the sender of the PDFvt file and how many recipients you have in the tree. To the next level, which I could imagine is the recipient level, I could have the name and the address and maybe the zip code of the recipient. And then at the bottom level, I could describe what kind of document parts I have here. So for example, the pages for one specific recipient could always consist of a statement and a promotion part. So document part metadata is application-specific metadata. The standard says nothing about what you have to put into this DPM nodes. It supports arbitrary PDF object types. There's a difference, I will point that out later, between PDF 2.0 and PDFvt, because PDF 2.0 does not allow streams in the document part metadata. So what should we do with these objects? There is a recommendation what kind of metadata you can put into the document part metadata. The ICS common metadata for document production workflows contains all kinds of meaningful attributes that you can attach to the DPart nodes, and these are typically referenced later than from JDF job tickets, job definition format job tickets, to, for example, describe a certain production scenario where you want to put the pages on a specific output device. So a quick introduction to PDF XObjects if they are not known to you. The XObject is a PDF term for external object, an abbreviation for external object, and this is a self-contained content stream for defining a graphics object. That could be an image, it could be a font, so text data, whatever, and it is inside the PDF file separate from the content stream in which it is used. And this is hierarchical. You can reference XObjects from other XObjects, or you can reference them from content streams of pages. So this is an important feature of PDF for defining recurring graphical content that is repeated on maybe many pages. This saves space in the file, and PDFvt defines several features on top of XObjects that allow optimized rendering of these XObjects. So the first feature I want to present to you are the so-called scope hints. A scope hint can be attached to an XObject, and it will tell the PDFvt reader how many times the XObject will be referenced in content streams. So there are several possible values for the scope hint: unknown, single use, record file, stream, or global. So, for example, single use means that the XObject is used exactly once when rendering the PDF file, and this allows the optimization that the PDF reader can throw away the cached rendering of the XObject once it has used it once. So this allows that it frees up memory for caching other objects, for example. On the other hand, if I have scope in file, then the PDF renderer knows it must keep a cached copy of the XObject until the end of the file, because it will very likely need it another time. If it would throw it away, it would have to render it again another time if it's used once more. So this allows optimization of the usage of the cache memory, and it allows the RIP to hold the objects in memory that will very likely be used once more. Then we have another attribute that can be attached to XObjects for uniquely identifying them. There's an GTS XID entry, an attribute in an XObject dictionary, and there you store a unique identifier for an XObject. And this allows the PDF viewer also to access cached renderings of an XObject. If it encounters another XObject that has the same unique identifier, it does not need to render the XObject once more. It can just access a cached rendering of the XObject. So that also allows efficient processing of PDFvt files. Next thing, encapsulated XObjects and transparency. There's a definition inside the PDFvt standard that defines what encapsulated XObject means. An XObject is called encapsulated if certain relevant parameters of the graphic states are explicitly set. If you don't do that, the context of where of the content stream where the XObject is referenced could influence how the XObject is actually rendered on the page. And that is, of course, bad for caching, because if the context affects how the XObject is rendered, you cannot cache it. You must render it every time again. So for an encapsulated XObject, this is not true. All the relevant graphic state parameters must be explicitly set. If you have a document where there is no transparency at all, you can simply mark any XObject in the document as encapsulated, because you can render all of them consistently without having to process any transparency on the page. If there is any transparency somewhere in the document, then all the XObjects must be defined as isolated transparency group, which also means that there is a defined rendering of transparent objects, which in turn allows caching of these encapsulated XObjects. So all this comes together that the encapsulated XObject can be rendered consistently independent of the content stream context where they are referenced. So I skip this. This is just for completeness, the environment context. Okay, then MIME support for streaming. This is a special encapsulation format for PDFvt files. And it uses the MIME format for packing multiple PDFvt files together in a stream that can be sent to an output device. And the intention is to enable PDFvt readers to rip or to print the files while still the PDFvt files are generated at the same time. So I've created a small picture here. How such a stream could look like. So the yellow rectangle put together is the complete MIME stream. The standard defines certain MIME attributes that you have to put into the MIME stream to identify the different parts that are contained in the stream. And the requirement is that all the parts that are needed for rendering actual pages appear in the stream before the actual page data. So the actual invoices, for example, could be contained in PDFvt2 files here that I have at the end of the stream. We remember that certain PDFvt standards allow referencing external graphical data or ICC profile data. So we have here a PDFvt2 file that is at the same time PDFX4P conformant, which means that it references an ICC profile that must appear before the file in the stream. And we have a file, for example, that conforms to PDFX5PG, which means it can have external graphical data and an external ICC profile. So this could reference two PDFX files that appear before the actual file in the stream and an ICC profile. And we can have here an PDFX4P file, which also references its ICC profile that appeared before the file in the stream. And how can you decide which files are referenced and which files are actually printed? The difference is the content disposition attributes. The files that are actually printed are have the attribute inline, content disposition inline, while the other ones have attachment and the file name. So from there you know which ones are the ones to be printed and which one are referenced. So what does this all mean to you if you want to implement a PDFvt writer? First of all, you must have PDFX support. Without that, it's not possible to create PDFVT files. So if you just want to cheat and write on your marketing material that you support PDFVT and you have PDFX support already, then you could very easily claim PDFVT support by putting the PDFVT file identification into XMP and implementing the DPart root dictionary and reference all the pages in the document from a single DPart node. That would be a correct PDFVT file, but it's more or less useless. None of the features you will have no features in there that make any optimization possible or any advanced processing. So what if you want to support advanced production workflows and JDF job tickets, which will be, of course, more difficult? You need to implement arbitrary DPart tree structures, and you need to have document part metadata in the file. Then you can use all the features that allow you, for example, to send different parts of the PDFVT file to different output devices, or you can select subsets of pages by metadata. And most difficult is, in our experience, to support the high performance features. Then you need to implement encapsulated XObjects, unique XObject identifiers and scope hints, and to guarantee that it's a valid and consistent file, you need to implement lots of consistency checks. What are some nice to have features? Not so important, probably the XObject environment context and PDFVT 2S. So the PDFVT 2S support is really just creating a MIME wrapper around multiple files, which you can write in a few dozen lines of codes in our experience. So do I still have time? Yeah. So I'll talk about a few problems in the standards, because then Duff will make an announcement and then we can still have some discussions. I'll pick some of these problems and I'll skip some. The first problem I want to talk about is that the document part metadata is not required to be self-contained. Nothing in the PDFVT standard says that you cannot reference PDF objects outside of the DPM substructure. So you could reference arbitrary pages, you could have recursive data structures, you could have streams inside there. And there are several problems we identified. One problem is that the standard defines an XML representation of the document part hierarchy that includes DPM, but this XML representation is not able to describe recursive data structures or describe references to objects outside of the DPart DPM structure. Another point is that PDF 2.0 will not allow to put streams into DPM. So there's a difference between PDF 2.0 and PDFVT. What can we recommend here? You should only create self-contained DPM without recursion, and probably also without streams if you want to be compatible to PDF 2.0.
For what it's worth, that was actually by design. The rationale for why it allows for both of those things was that there were members of the PDFVT committee who had very specific use cases for their particular workflows, but they wanted to be able to reference out to other PDF objects from the DPM, whether it was to XObjects or to page dictionaries or something else. So that was the rationale for allowing the export. And the streams, same sort of thing, which is where they had certain types of data structures. Like, for example, they wanted to put a blob of the FXML in there. Or they wanted to put XMP, real, quote, real metadata as opposed to using DPM there were use cases for that, which is why we enabled both of them in VT proper. And since the XML was only being used for JDF, that wasn't a big deal. We didn't see those as showstoppers, although your point is well taken. You can't bidirectionally do that, but it wasn't seen as a major problem.
Yeah. Then one thing that came up during last year's conference are restrictions for DPart trees and how they are intended. You remember that the node name list array describes or gives names to the different levels in the document part tree. And there's a statement in the standard that says the number of entries present in this array shall be equal to the number of DPart node levels in the document part hierarchy. So you must have at least one DPart tree leaf node at the level that corresponds to the last name in that array. The tree must be so deep at one place at least as how many entries you have in that array. But there's no explicit statement that all leaf nodes must be at the same level. I want to illustrate that. So here we have a DPart tree, and the node name list contains ABC, which corresponds to these levels in the document part tree. We have all the leaf nodes of the document part tree at level C, and the statement or the requirement is fulfilled. We have 3 entries in the array. We have 3 levels of DPart node levels. So this is, of course, conforming. To give a counter example, we have a document part tree where the leaf nodes are at level B, and we have no nodes at level C. And you can clearly see that this tree is not conforming. We have 3 entries in the array and only 2 levels in the tree, so this is not a conforming PDFvt file. And we could have a tree that looks like this, where the leaf nodes appear, so at least one DPart node must appear at level C, but you could have leaf nodes that reference to the page tree at level B as well. And if you count, you have 3 entries in the array and 3 levels, because we have at least one node here, and this is conforming. Some people disagreed at last year's conference, but the consensus is, as far as I know, that this is conforming, and Acrobat validates this as a correct PDFvt file if you have such a document part structure. So you should check with your PDFvt consumer whether it agrees to that requirement, or whether it allows these kinds of document part trees if you want to produce those. Okay, this is esoteric. I talked about the stream objects already. What is more interesting, and we discussed that recently on the mailing list of the technical working group, is the 2 GB file size limitation. The conclusion is like this: PDF X4 is based on PDF 1.6, and there's a sentence in the PDFX standard that says a PDF X4 file shall not violate any of the architectural limits in the PDF reference table C1, where it says an integer may only be so large, so 2 billion something, and this means you cannot have any file offset that is larger than this number in the PDFX file, and this effectively limits the size to 2 GB. And we ran into this because we had properly implemented that check for PDFX files, and a current customer who's working on PDFvt support complained to us, why can't I create files larger than 2 GB? So I think this is a problem, a real problem for PDFvt producers, because this is not uncommon today that you want to have such large files. And we decided to relax that check in our software. And I think others do the same. We had feedback from a validator from PDF tools. They said they ignore that because it doesn't make sense. And I think in the technical working group there was also a discussion about this yesterday.
Yeah, this was actually the somewhat easier one, because we think that we can avoid, assuming we can get all of the validators to agree, because we still haven't heard from all of them. We believe that by simply classifying the file offset found in the XREF as a data structure that is not an integer, which is not an unreasonable statement since it's not written in the same way, at least in a classic, then it's not a problem for a classic XREF. We think that's a reasonable thing to say, and it would be okay. But that would only work for a classic XREF, so it would not get away from the problem in a compressed XREF, in an XREF stream, because there it's very clearly an integer. But there you have other alternatives, which, as we discussed on the mailing list, you could do, by shifting things around, would get you greater than 2 gigs, although not unlimited.
Okay, so there's something.
Real change we would have, and that I assume will go to the other one, which is actually the thing we really are going to have to take back to the committee. Okay.
And finally, that's also just an experience from last week where we had still a problem in PDFlib when linearizing PDFVT, so optimizing for web download. You might ask yourself, why would you want to linearize a large PDFVT file?
I was just asking myself, why would you do that?
Well, we asked them, why would you do that? They said, we want to have a quick preview over the web, and linearized PDFVT is especially useful for that, because you can quickly look at the first page whether it looks meaningful or not. So we agreed that this is a use case, and if you read the linearization specification in the PDF reference, it has a statement that all objects that a page object refers to an arbitrary depth, except page tree nodes or other page objects, must be put in the so-called first page section. So this is a section that is very near to the beginning of a linearized PDF file that can be downloaded as the very first thing to the web browser, to the plugin in the web browser, so it can quickly display the very first page. Unfortunately, every page in the PDF document by definition refers to the whole document part tree. Each page object has a back reference to the document part it belongs to. Each document part node, I didn't have that on my slide, but it has a back reference to its parent document part node, which in the end goes up to the document part root node, which in turn goes down and references all the document part nodes in the document, which means there can be a really huge data structure put in the first section, which somehow foils the intention behind linearized PDF. And we analyzed that, and Acrobat does it like that. If you linearize a PDFVT file, it puts the whole document part tree into the first page section. But what we also found out, if you put the document part tree in the other object section, it will also work. So that's what we are doing now. We ignore this statement, and there's another statement in the PDF reference that says only include the documents that are needed for rendering the first page, which is clearly not true for the document part tree. You don't need it to render the first page. So we put it in another section in the linearized PDFVT file and make the first page section reasonably small again, resulting in a quick display of the first page in a PDFVT file. Yes, please.
Is it a requirement for PDFVT2S to have a linearized PDFVT?
No. But you can linearize.
If you stream it, then and you want to render the first page, then linearized.
You don't do it that way. We actually talked about when we were trying to design what's now called 2S. We talked about using linearization or extending linearization as one way to solve a problem. And for a variety of reasons, we didn't go down that path.
Yeah, so 2S, the chunked implementation, so that we avoided that problem.
Basically, if you wanted first page out quickly, then you create your 2S chunks, where the first chunk is one page. And then you can chunk it, and then you can create smaller, progressively larger chunks as you go along. Yeah, no, in fact, In fact, we probably should have totally disallowed linearization in VT. We never thought about it.
Yeah. 20/20 hindsight always works beautifully.
Okay.
But unfortunately, the folks at PDFlib will be bringing all of these comments to the standards committee so we can get them all addressed in the future.
Right.
Probably, yeah. Okay, so we are at the end of the presentation already, then Duff will take over, and then we can have some more questions. There are a few problems in the standard, but from our point of view, they are not really big problems, and they are only present in edge cases, and you can avoid them or work around them with common sense. It's not there are no real showstoppers. From our experience, PDFVT has not really taken off yet, so we have some large implementations underway, but for example, we did not get any complaints from RIP vendors or something like that they have a problem with what we put into the PDFVT files. And we would expect that if somebody uses this in production, then some questions will come up for sure. Yeah, and that was not.
Did you actually give these to RIP vendors to effectively run, or that it's unknown? That's unknown to us. But if somebody would do it, we would expect that we would get feedback on this. So that's the last statement. Very little is known currently, from our side at least, about PDFVT consumers and what they do with it. We are still waiting for that, but this will come.
We have very little time at this point before the concluding thing in the main room, but there's a perfect lead into something I wanted to discuss relatively quickly. No slides, but very simply stated, one of the problems that PDFVT has suffered from is the chicken and omelet problem. Which came first, chicken, egg, etc. If you talk about people who, about end users, print service providers, well, what creates PDFVT, what consumes it? You talk to the people who would create PDFVT, well, what consumes it and who would use it? And we have no examples of it. You talk to the RIP vendors, even though Adobe and I believe also Global Graphics have both implemented caching algorithms and everything to deal with PDFVT, the ultimate implementers in terms of the vendors who sell printers based upon this technology, well, we don't have samples, so we don't sort of know whether the, so if everyone's pointing a finger, if only the other side did something, we would go with this. So I got tired of hearing this. It was very tiring to me. So one thing we're going to announce at Print 13, and some people have heard about this already, is that Adobe ganged up with Cal Poly in San Luis Obispo, it's their graphic communications department, to produce some test files, some application test files with PDFVT, large numbers of records, large number of pages, graphic complexity. In this particular case, we started off with one application that we knew happened to produce valid PDFVT. That's not talking against any others, but rather this was one we happened to know, and we can only do one at a time. We took XMPie's product that is a plugin to InDesign. I took a bunch of students who didn't know how difficult it would be to do this, do the design work, taught a course on PDF reliable print workflow, did a lot of driving back and forth within California, and by the end of the summer we will be releasing test files, 4 different campaigns, so to speak, different types of themes, graphically rich, up to 20,000 records per, with 10, about somewhere between 8 to 12 pages per record. So these are reasonably large files. They are reasonably representative, we believe, of what might go out up there. So no one will come back and say, well, you just tried to gimmick up something that would be so difficult that, you know, it would choke a horse. And we are going to make these publicly available. And I'm currently talking with a number of organizations. Possibly we'll put them on the PDF Association website. They will be free. We will make them available to the entire development community, the entire user community, etc. There's only going to be one requirement, that you can't change them. In other words, you can use them for demonstration purposes, for test purposes, you can analyze them, but you cannot change them and use them as a demonstration. So we don't want anyone sort of cooking the book, so to speak. We'll see how it goes from there. It'll be a good challenge. There's certain things we've learned about the implementation. We've learned about how you create these things. Some of the things you can run into in terms of problems. I've been in constant contact with people at XMPie in terms of how they're generating these things that they did right, things that they did wrong, etc. Features that they put in terms of DPM that I know my RIP vendors haven't implemented yet. I think what you're going to see on initial implementation, and some of this will appear at Print 13, is that some initial print vendors have implemented the caching, because that's built into the Adobe PDF print engine, but they haven't done anything with the DPM. So I can't easily say for all left-handed herniated New Jerseyites who live in a certain range of zip codes, print the cover pages to their particular thing, and then some other time print the text pages. Okay, because that metadata will be there, but you have to build a user interface in front to be able to access that through the RIP. So we're going to provide a number of challenges to everybody along the way. They're not going to be perfect files, but it's a first step. I was tired of hearing complaints that didn't exist, so we're going to be doing this. So this is one of the first places we're discussing this. I mentioned at the GET work group, I mentioned at the ISO committee. You'll be hearing more about this. Okay.
So if you're looking for PDFVT files today, you can get them here. We have code samples for PDFlib together with the output files, and they are not really sophisticated, so I'm looking forward to see those files.
Oh, yeah.
They have a few dozen pages, I think. They have some simple DPM structures, but they are not really sophisticated with transparency and things like that. So you can see the general data structures, but we take it as a suggestion that we also will produce large, sophisticated PDFVT files so people can look at them.
Yeah. By the way, we're not restricted to the XMPie type of thing. Other developers of PDFVT solutions are more than welcome to have a discussion with me about things that we might do to extend this test file series using their products. So pass the word around.
Thank you very much.
Does that mean that products like Doc1 and Stream Server and ISO?
If they're willing to provide some students,
they are not there yet.
Well, I don't know. Let's put it this way: by putting some files out there, we're going to get people coming out of the woodworks. You know, sort of, oh, I have something, try it. And this we hadn't had happen before. So I had to put a stake in the ground, saying, "Here, we have some stuff. Anyone else?" And I think that'll happen. And all it takes for anyone to participate in this type of process is basically have a product that is working reasonably well, and be willing to donate enough copies of it for me and some students to be able to use it. That's a simple thing. It doesn't require computers. It doesn't require donating printers or anything like that. Yeah, I think we're sort of past our time. We had a 4:30 end time. So I'm sure that there'll be further discussion in the hallways and over beers, lunch, dinners, etc. Thank everybody for participating in this set of sessions today. The speakers were very enlightening and controversial and informative sessions. And,
no controversy. We all agree, right?
We all agree it's controversial. You're right.
No.
Okay.
Thank you.